Yeah, I wanted to create a quick video demonstrating a few things with like mixed numbers and operations and really the why behind all of this. So one thing I wanted to point out first is like 2.5, right? 2 and 1/2 really is saying like we have two, I'll use pizzas for instance, two full pizzas and then 1/2 of that same size, right? Purple pizza, whatever. But ultimately, when we're talking about this, we're talking about one whole plus another whole plus a half. And our whole numbers we can group as the two, right? And then we have this half. But ultimately, like my point is, we have two plus a half. That's our mixed number, right? And some of these, yes, they're convenient when we first like begin operations to think of like 2.5, but fractions are exact answers, right? Where as we begin to teach these in grade school, we don't want to always convert because this 3 and 2/3, right? I could draw that 2/3 in a picture, no problem, but when I go to make that decimal representation, right, the 3 plus 2/3, at some point we're telling them we have to round, right? Or the 3.6. I mean, it's um, it's not exact. So we don't always want to convert to decimals here. So one concept is if we think about these with addition or subtraction, we often will group these vertically, right? Like 2 and 1/2 plus 3 and 2/3, and then we treat these part of a whole, right, the fraction pieces, um, separately and proceed with our addition. And we really do kind of think of, all right, the wholes are 5, and then we get some other piece over there. And yes, we do carry over as needed. But then the question is like, well, with addition and subtraction, we kind of look at that. So a multiplication, even if I set it up vertically, right? Why can't we do the same? Why can't we multiply these fractions here and then multiply these and then combine our answers? Um, and without really doing the work. I mean, I didn't even finish the addition here, right? I'm looking at the why, the concept behind this. Why does it not work? Too often we just give these kiddos the rules like, oh, here's how you do it. You can't multiply mixed numbers. You have to change it to improper. And then we teach them some, there are plenty of acronyms up there or directions like multiply these and then add. And, you do some arrows or whatever your trick is, right? But that doesn't really explain why this process here is incorrect. All we're doing is showing them some new algorithm, some new rule, and not demonstrating, whether it's with a picture here or, however that looks. Sometimes pictures are hard to do, but we have our visual learners, right? We really need to think about the why. We need to break away from just all these rules and algorithms and acronyms to address the concerns that they have. Okay? Showing another example with another algorithm over and over and over. Like, I mean, if I do this 10 different ways and they still make this mistake trying to break it apart, then have we really done them justice, right? Have we shown them why it doesn't work? And some of them are challenging. Some of them, to truly understand why, it's a process. So I want to focus on this multiplication in two quick ways. Why did I begin with breaking it up into this to begin with? Well, if you think of multiplication, okay, when we multiply across addition, we use what we call the distributive property, right? So 2 plus 1/2 multiplied by 3 plus 2/3. If I only chose, let me get a different color here, whatever, we'll do rainbow. This one, okay, which was here, right, 3 times 2, and this one, remember the distributive property, and maybe they didn't learn FOIL yet, that's okay, they still, to some capacity, have learned distributive property. That begins to show up at second to third grade standards. They learn it in some capacity with whole numbers. So we're breaking that up now and extending it into fractions, into rational numbers. So that's okay. But notice, right, they didn't fully distribute. What about this 2 times 2/3? That is missing from above. Okay, again, we had the 2 times the 3 is 6. We had the 1/2 times 2/3 was whatever that is. I mean, it's 1/3, right? But the result is not important. The y is what I'm focused on. So we had this one, we had this one, but we don't have that outer distributive property. We don't have this inner distributive property. Okay, that was completely neglected by that method chosen up here. Okay, that is one way to show like why that doesn't work. Now, yes, of course, creating improper fractions, right, by using that technique, creating 2 and 1/2 as 5/2 and creating the 3 and 2/3 as 11/3. Of course, that is a shortcut. That is great. That is wonderful. But how do we break beyond these misunderstandings? How do we break beyond those barriers, right? Here's one more sidebar explanation I would like to show. And it doesn't even have to involve a fraction. We could go back to just some multiplication with 2-digit numbers, for instance. Why can we not just multiply straight down? Well, same thing here, right? I don't just do 5 times 2. We don't just multiply these and then multiply these separate. Okay, that doesn't work. This unit, this ones unit, is being multiplied to the ones unit here and the tens unit there. It's being multiplied to the entire 25. So therefore, just like distributive property, right? If we look at this, what I'm doing is I'm taking this 2/3 and I'm multiplying to both. I'm multiplying to both terms. Multiplication requires distributive property across addition. Then I'm taking this tens, this 30, right? And I'm doing the same thing. So really, even back to just 2-digit numbers over here, I have 4 multiplication, 4 products to consider. Okay, I have 4 products. Okay, addition is different. It does only require combining, right? Like within the terms there and regrouping. And again, why? We could break that up too, because addition, if I rewrote even this here, we have 2 plus 1/2 plus 3 plus 2/3, right? Addition is I mean, follows both associative property and commutative property. I could rearrange this to however I would like. So I could add the 2 and the 3, right? And then I could regroup and add the 1/2 and the 2/3. I hope this helps. I know it's not direct. I know there's some sidebars here, but learning to teach, right? Learning to get through to our students. It's not always about us and our teaching. Like we could again go over rules and algorithms and acronyms and techniques all day long. It's about student learning. It's about connecting with them. It's about showing these multiple ways to get through to those students who just aren't getting the algorithm you share. Okay? The acronym just isn't hitting home. How can we make that connection? How can we break down that barrier of demonstrating why what they are trying isn't working?